out on Slooh. I did some projections here. The first Slooh moon mission we're going to get for the moon is really going to be Friday. And I'm wondering if maybe I should take a look at that now. Yeah, let's take a look now and see why that is. So not only is the moon close to the sun, but it's at a very oblique angle. It's not a very steep angle, which means that it's going to be difficult for us to get a decent image of the moon because the moon simply isn't well placed. Where are we here? So let me get my time out. I'm going to advance the time and we'll see exactly where we are. So I think we're about 20
Question.
hours is when the sun sets. Yes, go ahead, King.
So is the moon visible with the naked eye then, if we see it like that?
In theory, it should be, but it isn't, because if I turn on my atmosphere, this is what you've got. So even if I advance to an hour, to see how close the moon is to the horizon, I need my grid actually, don't I? You're less than 5 degrees. So it's very, very close to the horizon. It would be very dim to see this teeny tiny crescent. And certainly the Slooh telescopes would not be able to capture the moon yet, because we have to be at about 30 degrees above the horizon. So 18 is today, Tuesday. Wednesday is the 19th. The 20th is Thursday. I'm looking at the first moon missions being here on Friday. So 21 hours, 8:20, we should be about here. So we're, 20, 25 degrees above the horizon. This is what I am showing for the first lunar missions on Slooh on this particular cycle. So one, it's very close to the sun. It's also very low. That's why we have to wait. Can you see it before then? Let's look at how much of the view of the moon we've got. Moon age, 3.8 days old, 15.4%. We've had 4 or 5 to 7% moons on Slooh. So yeah, you should be able to see it, but for right now, because of where the moon is in the sky, if you notice, it's a very shallow elliptic line. It's not very high. So it isn't high to begin with, and it's very close to the sun. So we're looking at Friday before we can even get a waxing crescent moon. So that's why we have to wait. Let's go back to our virtual moon atlas, and let's look at some of these lunar features. Craters were the first one. Here we go. Go back to virtual moon atlas. So if you haven't used this program before, it's good up until a point. I haven't used it in quite a while, and I had forgotten how helpful it actually can be for some things. So you have a little date time stamp up here in the right-hand corner, and I can advance the date, or I can just click on the phase of the moon that I want. So maybe let's look at first quarter. So we talked about this yesterday, the terminator, and we can see some lunar features already. Now, the first one in the lunar phase quest, and we'll just kind of follow it in order, were craters. So we see these different types of craters. I'm going to go full moon on. All right. So we see these different types of craters. A very prominent one and very prominent type is this crater, Copernicus, and we can see that it has a type of ray effect. We have another one here where we've got the crater in the center, Kepler, again with this material that's spread out. Then we have craters like this that are just kind of plain. We have this type of crater. We don't have the ray effect. So who wants to take a guess of why they think that some of these craters, we looked at this one yesterday, this is Proclus, which has a ray effect, but in one area only. So who remembers from yesterday, or who wasn't here yesterday, wants to take a guess of why we have different types of craters? Some of them have these rays that we call ejecta material, and some of them don't.
Because they're formed in different ways. Some are formed from volcanic activities. Some are formed from asteroids or meteorites hitting.
That's right. Some of them are impact craters. Some are formed from volcanic activity. So let's look at Archimedes here. This kind of looks like a sea, doesn't it? With a ridge around it. So we would think that this could be from volcanic or tectonic activity. Plato, another one. The ray effects would have been an impact crater, right? Something struck this and caused the material to blow out in all directions. We're going to look at a great animation that somebody had put together in observations of what exactly is happening here. But we can definitely see them, right, in this area. Kepler here, very, very nice, well-defined ray effect, right? You can imagine a meteor striking the surface of the moon head-on and causing the rays to shoot out in all directions. There's a very famous crater down here, which doesn't show the ejected material on this model. So that's why I said it's not good for everything. And you can see all of these different types of craters. These are all kind of pockmarked on the bottom. Tycho is the crater I was looking for. This looks very different, even when we see it on Slooh, and we'll look at some Slooh images. This is definitely, an impact crater with ejected material spread out in all directions. But in this model, for whatever reason, this is like one of the most famous craters on the moon. It doesn't show that. And yesterday we looked at this crater here, Proclus, which is a type of rayed crater. We have some ejected material, but nothing on this side. So when the meteor approached here, it obviously came in at an angle and kind of slid into the surface of the moon and sent all of the material in this direction. But this direction doesn't have any because it didn't hit head on. All right, so let's go back. Craters, different ways of forming. All of them, for the most part, have names. And there are new craters. Things are hitting the moon all the time. Every now and then, somebody will see something that we didn't see before. So that's also something to look forward to on Slooh. Now, all right, let's go. Yeah, I wasn't going to go here yet, but we may as well. So this is an actual Slooh image of the full moon. That's Tycho. Okay, that's the crater that didn't show the ejected material. Pretty obvious, don't you think? And Copernicus and Plato and some other things. Well, since we've got the full moon here, in addition to craters, we have these things called mare, or maria, the plural Latin word for sea. Those are the dark spots, the dark areas on the moon. And as you can see, there are a lot of them. We had a question yesterday about this. No, these aren't water deposits on the moon or oceans or anything like that. They're just called that because that's what they look like. For people looking at them on Earth, even with the naked eye, you can see these dark spots. And in fact, the Astronomical League has a naked eye moon observation program. And one of the ones is identifying the Maria, the seas on the moon. So what's happening here? Lava. These are lava flows. The moon has a lot of basalt, which is a type of material underneath its surface. And due to tectonic activity, we have these underground oceans of lava bubble up to the surface, and it just kind of smooths over and gives it this very beautiful, smooth looking surface, at least from space or from a telescope. And you can see them, they're all over the place. Some of the craters that we looked at look like mini Maria, but they aren't. Plato is one of them. But then we have areas like this. Again, this is Endymion. This is Mare Humboldtianum. So one is a crater that was kind of formed with this lava material, basalt. The other is simply a Maria. So, how do we determine one or the other? I like to just think of size. If a crater is, if we see a C and it's not big like this is, that's more of a crater that was formed in pretty much the same way. All right. All the C's are named. As I mentioned, Mare Crisium is my right limb of the moon. When I see it out here, I know I'm going to see that extra 9% of the moon that we don't always see, and we're seeing it here. Multianima you don't see, Mare Marginis you don't see, Mare Smithi you don't see when it's close to the limb. So that's one of my key indicators. The three very famous Mare, the Serenitatis, Tranquillitatis, which is where the Apollo 11 moon landing was, Fecunditatis, and others. We'll go back to the moon map and we'll take a look. You do have to have access to a good moon map. Let me go back. And this is a good place to start. It has all the Mare labeled. You can go in and tweak the settings, but what I usually do is I just scroll in. So we're going to talk about lunar movement tomorrow a little bit, celestial mechanics, that kind of thing, and talk about how the moon moves and how it orbits and how sometimes it's closer to the Earth and farther away from the Earth. But this particular example this month, we're going to have favorable libration, and we're going to see some of these things we don't usually see. Mare Marginis is one, Mare Smithi is other, all of these things on the limb. And we'll talk about, again, libration tomorrow. So you can see all the C's are labeled. These are kind of the big ones. We get up into Mare Imbrium. Sinus Iridum is where we were yesterday in Galileo's drawing. I think it was actually talking about this entire region, this Mare Imbrium region. You have this enormous ocean here, Oceanus Procellarum. It's kind of like the entire left side of the moon. It's very, very large. So the Mare, to me, are one of the most beautiful lunar features that we have on the moon. That's why I like the full moon. A lot of people don't like the full moon. The full moon interferes with deep sky observation, right? And for deep sky imaging, the moon is the brightest object in the night sky. So when we have a full moon, it kind of washes out all of these faint details. So a lot of people don't like the full moon. But I love the moon. When we have a full moon, that's kind of like a moon holiday, right? That's the time that we use to look at the moon. And as I mentioned, the full moon is beautiful. The Mare are very, very obvious from Earth without any type of aid whatsoever. Just looking up at the moon, you will see these dark patches. And of course, if we have an opportunity to turn the Slooh telescopes at the full moon, wow, we get a great picture. Let me go back to that full moon image one more time, and we're going to go back to the quest, I promise. When we are using the Slooh telescopes, if we want a full moon image like this, we have got to use Canary 2 ultra wide field. Either that or the ultra wide field in Chile, which is Chile 2, I think. Let's take a sleep break and take a look exactly where these are. This is important to know. I have to make the moon go away and get into my cane. Go ahead while I pull this up.
Also, the Canary 1 half-meter telescope works really well. It gets the same image. It's closer in, so you get the same image, just it's a little closer.
Do they use?
I have like a couple really good images from Canary 1.
Let's go to Slooh. Sometimes I get things mixed up. All right. So let's take a look here. Everything is in a slightly different spot. Telescopes are here. So is it Chile 2? Yeah. Okay, so both wide field telescopes. All right. We're not going to use the Chile telescopes here because they're not online tonight, but they're also not online when we have astronomy camp. But going back to what I was talking about with Canary 2, it's the ultra wide field that you want. Now, very
This
rarely,
is Slooh. I'm Bob
sorry,
Dorman
Bob,
here
I
to
got
explore with you a unique
commentary. Oh, they're going to look at Ceres. This is a minor planet. We were just at opposition with Ceres not long ago, and it was gorgeous. We're losing some of that definition that we had. All right, getting sidetracked. Very rarely, you will see moon missions scheduled to Canary 1. This is not the best telescope to use for this, and usually it's Slooh Ops that will schedule missions. If we're doing something that's a little more unusual, like if Paul is running a moon star party, sometimes he'll pull out Canary 1. The reason we do that is because Canary 1, this half-meter telescope, is designed to pick up very distant, very faint objects, things that you cannot see. So to take it and turn it to the moon, which is the brightest object in the night sky, is counterintuitive. And in fact, it doesn't damage the camera, but it does flood the cells, which means if we schedule a mission to Canary 1, which is a 10-minute mission, it's twice as long as the 5-minute mission, you will see ghosting of the moon for about an hour, which means you'll see the next object and you'll see an image of the moon, like a double exposure in that image. They have to actually flush the CCD camera to get out all of that extra brightness and stuff. There's some technical stuff that goes on there for that I won't go into. So we don't normally use Canary 1. Canary 2 ultra wide field is the one you want to use if you want the full moon image. If you want the lunar phases zoomed, I'm sorry, the lunar features zoomed in, that's where we want Canary 4. Canary 4 gives you a different view of the moon, or zoomed in more. You'll see what I mean. Let's look at this one. This is a Canary 4 image. This is a full moon image, but we don't see the full moon. We are zoomed into the full moon. And here we can see, I don't know if Carol had done some processing or not, the mare are nice and dark, beautiful. We see these craters, very, very bright. Aristarchus, the famous crater on the western side of the moon, in this sort of floating out there in Oceanus Procellarum, very bright, brilliant. Several of these craters on the moon give us that effect. We see some ray effects, right? The ejecta material, you can see it. Great shot. But if you want things like this, if you're going to work on the lunar phases quest, the lunar features quest, this is the telescope that you want to use. You want to be on Canary 4. All right, let's go back to our quest. So we looked at some craters. It's next on our list. I think Mare, we already covered that. Lunar montes, mountain regions. So this gets easier as we go along, doesn't it? We're just going to pull up this image here. Just like we have mountains on Earth, we have mountains on the moon. We have a very famous mountain range here. This is Montes Apenninus, which is the highest mountain range on the moon. And in fact, we have an observation about this. So this is that mountain range. We can see some shadow being cast, right? The light source is over in this region somewhere. How do we know that? Because we just look for the shadows that are cast in the mountains. Shadow is behind the light. The light's here. The rest of the mountain range is in shadow. Let's read what Cameron wrote here. Read more. So yeah, he just scheduled some missions to look at this mountain range. I don't know if you tell us how tall they are, but he doesn't. Okay. But a lot of these mountains on the moon are higher than the Alps. Okay. They're higher than, some of them I think are higher than Everest. They're higher than some of the highest mountains here on Earth, despite the fact that the moon is actually quite small. I want to, where is my, I want to show my experiment since we're here. Scrolling back and forth, sorry guys. All right, let me go to my magnifying glass. I have to find my moon. Okay. Don't remember where this was, but it's an important graphic that we have to use. I'm going to backtrack a little bit. We're going to look at some of this ejecta material. So if you scroll down, if you go to Moon in the Guides, remember all I did is I went to the magnifying glass. I am on the object page, the guide page, and we can look at any of these phases that we want to. That's where I took that from. I have this saved. I'm determined to find it. I'm sorry. Do we have any questions while we're doing this? We're taking a little Slooh break here. Gretchen, maybe you can help me out. Look in the chat box.
Sure. Let's see what's going on. Yeah, no chat. We're quiet today. Everybody's like tuned into the moon. Anybody got questions or comments about the moon or the lunar mission? I know I've been following that website, Apollo 11 Live. Is that what it is? Apollo 11 Live?
Yeah, Apollo in real time.
Oh, Apollo in real time. That's what I mean. You know, every time I would type Apollo 11 Live, I could never get there. And then I remembered it was Apollo in real time, which is a fantastic site, which I absolutely love. And then I don't know if you guys have noticed, but the website has been reworked, and I encourage you to check it out and look at the new format. Kind of find your way around. Oh my gosh, look at all these great pictures.
Well, anyway, here it is. Here it is. So this is your impact crater with ejecta material. And you can see this looks like Tycho, that very large crater. And Cameron had done this. Cameron, I hope you don't mind my sharing your awesome work here. Change some of the exposure and the settings to show the huge impact. But you can see this. This is a very popular science experiment. You've got the lunar material. This is like your dust, right? And a large meteor impacts the crater, and you have everything spread out in different directions. So when we look at some of the other ones that come in at an oblique angle, you have this kind of effect, right? You have the meteor coming from a different angle, and you have some of the material spread out in one direction, but not in the other direction. So that was my big, I know maybe you're not as excited as I was.
I love it. You know what? Can you grab a link, the URL, throw it in the chat, and I'm going to add it to the workspace.
Yeah. I don't know if this is the one. I don't know if this will take you to the one.
Try it. Let's see what I can find.
Go into chat.
Eject.
I would take a look at this because although we are now very soon going to be able to edit our comments that we make on posts. You can always edit your post, but there is a feature now that's been added where you can edit your comments, but it's not working yet. It's not functional. So you can hit the link and see if it takes us there. All right, where were we? Let's go back to our mountains. Let's go to the virtual moon atlas. Let's look at some mountains. Let's look at some mountain ranges. So again, I have this in full moon mode just because they're easier to see. So these are certain features that you should know. The Montes Apeninos. You have, which is part of that whole chain of mountains. Up here in Sinus Irdum, you'll hear this region called a lot of times by its nickname, the Golden Handle, which lights up when the sunlight hits it in a certain way. Mountain ranges. And Virtual Moon Atlas is good for this because you can zoom in. With Slooh, you can't always zoom in. And if it's a little fuzzy, you don't get definition, you can't move around like I am here. So here's another interesting thing about these mare seas and the mountains. Mountains are also referred to as lunar highlands. So these are high points on the moon. And some of the mare are second generation. So you might have had an ancient sea, an ancient lava flow of basalt. And at a point later in the moon's history, you could have some activity underneath the surface of the moon, which would cause a second lava flow. But they don't affect the mountains. The mountains are higher than the lava basins, right, than these mare. So they're always referred to, you'll see them not just as mountains or the names that are given to the mountain range, but are referred to as the lunar highlands. And you can see certain areas, just like here on Earth, have them here. So go into Virtual Moon Atlas and play around and see some of these mountains regions. It's a little tricky sometimes, it's difficult to remember. These are the Jura Mountains. And see, it's not letting me, here it is, Montes Jura, they're using the Latin reverse word order. So that's this mountain range here, the Jura Mountains. Mountain ranges on Slooh. So let me take a break here. Questions so far on lunar features. We have a couple left to do, but I need to rest my throat. So Kane, go ahead.
So I'm confused. You're saying there were ancient seas at one point?
A lot of these seas, because they're lava flows, okay, may have been covered over more than once. So a lot of this is believed to have formed initially during this period known as the Great Bombardment, which is when all of these things were flying around, and that's where all these craters are coming from. And later activity could have also created lava flows that flowed over the seabeds that were there before. And one of the ways we know this is one of these lunar features that I guess we may as well look at now. Let's see where we are in our quest. I'm going to go back here and show this. This is one of the most elusive lunar features, what we're going to look at next. And when I see people post, it's this, lunar rills, valleys. Seems kind of simple, doesn't it? But it isn't. I don't think they have anything here. There are different types, but we're just going to look at some images of them. So when you're working on your lunar features quest, this is one of the things, one of the objects you have to find. Now, this is a very extreme close-up, but it looks like a riverbed, right? This would be a sinuous rill. It's this sort of serpentine pattern. And we can see we have a very well-defined flat region, like a basin, and these higher walls. And this is what, now, there isn't a consensus on what causes these, but one of the beliefs is that when the mare were being glazed over with this layer of lava, as it started to cool, some of this molten material would still flow through. So we see this on Mars, but I think the Valles Marineris, which is that huge trench on Mars that we looked at, I think that was actually caused by water, some of the underground water that was on Mars that we think at one time. This would have been probably caused by lava, even though it looks like a riverbed. Water would not have caused this on the moon. We think that instead it was lava. These can be very tricky to find on Slooh, okay? And I think a lot of people who do the Lunar Features Quest just want to blow through it and get it over with, because these are tricky to see, okay? We are very much zoomed in. And even though we see all these craters, the surface of the moon is still very smooth. So we have to imagine that this one is in sea. Here's, again, a sinuous rill. This is one of the types of rills that we classify. You can see it. It's kind of serpentine. It looks like a dried out riverbed. That's what a rill looks like. Then we have straight rills, just kind of like a somewhat straight line. You have a nice crater here. Sunlight approaching it from this angle, right? Then the shadow here. Different type of rill where it kind of branches off. So even though it's not water, it behaves the way the water behaves, doesn't it? I mean, if you look at satellite photographs of the Earth, when we look at like the Mississippi Delta or the Nile Delta region, that's kind of what this looks like, right? It branches out into different branches. Not water, though, probably formed by some of this basaltic lava as the Mare were going through different stages. Look at this one. So let's just look at this and unpack this. What a great picture. This is not a Slooh image. This is probably Lunar Reconnaissance Orbiter image. So before we talk about the rill, what's going on with these mountains?
The sun's hitting them.
Which direction is my sun?
The left.
Right. Yeah, to the right. Remember, our sun is, we can always tell the position of the sun. It's shining from the right and casting the shadow to the left. This is a very famous part of the moon. This is called Hadley's Rill. This was actually explored by Apollo 15 astronauts. They actually went here and checked this out. In some of the Apollo footage, I think it's the Apollo 11, as they're starting to land, as they're approaching landing, they use one of the rills as a marker. They say, we just flew over, and I forget which rill it is, over such and such rill. And as I mentioned, time and time again, the astronauts were not scientists. They learned all of this stuff. These guys were just courageous people who, were doing experimental test flights and passed all the tests and had the physical, health and stamina to be able to handle a mission like this. But they had to learn all of this lunar mapping in order to pilot and land on the moon. Don't forget, Neil Armstrong overrode the computer system that was supposed to land the Apollo 11 spacecraft because they were probably going to wind up in a crater, and he took control of the command and flew it himself. So the very famous Hadley's Rill, beautiful, with all this beautiful shadow material going on too, very steep mountains. And then we have this. This is a nice annotated thing that I picked up somewhere. So Oceanus Procellarum, that's that massive region right on the western side of the moon. And we have some craters here. We have Herodotus. Aristarchus, remember, that's that very bright crater. It's a very famous lunar feature. I mean, if you only know a couple of craters, learn the ones we talked about today. We have a rill here. So they give them names, so we can see how this might have bubbled out here and then trickle down until it ends, the end of the inner rill. And then there's a primary. We see it definitely on Mars. We see this with Valles Marineris, but I don't think it's volcanic material. I think it was water cutting through the ocean surface. So again, underground material bubbling up for whatever reason, tectonic action, right? Go ahead, Gabriel, I'm sorry.
Is this picture from a satellite? It looks like it's 3D. I mean, it looks like there's sorry, was this picture taken from a satellite, or is it taken from like a ground telescope?
I would imagine this is a lunar reconnaissance orbiter image.
Okay.
Just because I look at the definition, I mean, we get some really good pictures. The lunar reconnaissance orbiter, which is another great tool. We're not going to have time to talk about that today in full. For anybody who's interested, it produces amazing images. You can zoom in and see moon landing features. This isn't quite as detailed as that, but I'm just looking at where we are. That's what it looks like to me. That's where I think this picture, like I said, you know, I've been collecting images for, you know, Slooh, you know, star parties and the Tuesday shows. If a lot of this stuff, you know, isn't labeled, I don't remember where I got the original from, but I think that is it in this in this region. I'm sorry, in this section. So rills, that's what a rill is. So when you see that on the Lunar Features Quest, let me see, go back to that. That's what you're looking for. Okay, yeah, it's here. Doesn't matter which type so much. I don't think they ask me that, but you do have to know what a rill is. And if you want, you know, you don't get extra bonus points for this, but I have to imagine that a lot of people who work on the Lunar Features Quest don't get the rills correct because they're a little tricky to see. Let's go back to this full moon image and see if we can see some rills here. I think we're too far out. We have to go to a close-up. Let's go to Carol's image and see if we can see some rills. We've got the mountains, we've got the craters, we've got the mare. Hadley's rill, we'd have to go and find out where that is. That's, see, not as obvious. They're very faint and they can be difficult to see. So it's almost 10 up. Let's take a break for some questions, comments. There is one or two other lunar features in this quest. Let's go back. I didn't change my view yet. Go back. That screen's all over the place. Let's do this. Here we go. So we do have one other in the future, I think. And look what it did. All right. The mountains, the rills. We talked about the bright gray system. We went to that again. This is a feature that was added. Lunar swirls. I don't remember lunar swirls being part of the original quest. So Raynor Gamma. These are a feature I'm not really that familiar with. Does anybody know? Let's see here. High albedo regions on the moon that occur in and out of the marea. So lunar swirl. All right. So high albedo. Albedo has to do with the reflection, the reflectivity of the moon. It's not just the moon. Any object that reflects light. they call that the albedo. So I don't know. Do I see a lunar swirl here? Maybe if we go into virtual moon atlas, maybe we can zoom in. So we're looking for a very bright area, swirl type pattern, somewhere in the darkness of the sea. Ah, I see rill. Rills. Okay. It looks kind of like a bright albedo region in Amare, doesn't it? Is that what they're talking about? Has anybody taken this quest?
I haven't yet, but you know, it's interesting after you started talking about the reels, now you see them everywhere. Like, you know, oh, wait, look.
Yeah, and like I said, look at this area here. I think we were just there. Where's the Apollo 15? And there are other kinds of lunar features that we won't get to, like Rupes Recta, the so-called lunar straight wall, which is like a cliff that's on the moon. All these, oh my. Oh,
Getting excited.
do you see where we are? We're going to talk about this tomorrow when we talk about Clara Obscura, these
Yes.
patterns and things that we see in the moon. We have Carol's little man right here. We'll talk about him tomorrow. It's one of my favorite lunar features because it was discovered by somebody here on Slooh. Usually he's better when we're here. Oh, yeah. Oh, my gosh. How can you not see him?
Well, we're talking about it tomorrow, so we're not going to talk about it today.
Yeah, I know. Just don't get excited. Oh, didn't want to go that far.
Lights out.
So there's a little button here, compute. You see what I'm doing? I'm just scrolling up. I'll go into August 2nd, 3rd. Beautiful rills, though. And Amare. I don't really, never heard about the lunar swirl before. So I'm not really sure what it is.
Swirl?
All right, it's see what time it is here.
9 minutes.
Let's take a little break. Questions on the lunar features quest. Again, it's one of those collection quests. You have to get your pictures, but the thing is, you have to know what you're looking at, because unless I am mistaken, the quest, it's not a lot of the quests aren't smart in the sense that all you have to do, I shouldn't tell you this. All you have to do is fill the field, in some instances, not all. And that's why I think that not everybody gets the rules. I don't know. I'd have to look at the Moon Atlas. Maybe these are some rills here. It's hard to tell. But you need a good moon map. And that is the big thing. So let's go back. Keep talking back and forth here. It is important to have a good moon map. This is a good place to start, especially since it's free. It doesn't cost you anything. If I'm not mistaken, it is a cross-platform download. It's called Virtual Moon Atlas. You can play around with the different phases of the moon. They have a little handy guide here. You can just toggle back and forth. That was where we were. I can go to now. Not really much to see, although they do label some of the key features. Sorry. However, you learn some of these key lunar features. I think they're important to know. Know about the Montes Jura, the Jura Mountains, this mountain range here. Learn some of the Mare Imbrium, Oceanus Procellarum, Aristarchus Grimaldi. We didn't talk about Grimaldi. Remember how I said this? See, this Mare Crisium was my indicator on this side. Grimaldi is the one on the other side. That's our key indicator. to test libration on this edge of the moon, on that limb. Learn some of the craters, learn some of the seas, some of the mare, learn the mountain ranges, at least some of the basic ones. And I think that will help you in your enjoyment of the moon, whether you go outside and look at it live, or whether you just sit in the comfort of your own home and enjoy the moon here on Slooh. Either way, the moon is a fantastic object. And by having at least a basic familiarity with some of the lunar features, again, that will increase your enjoyment here on Slooh. Questions about the moon, lunar features?
There's no, just saying, just like asking, there's no chance that water ever exists, liquid water ever exists on the moon, right?
Not in the Mare, no. If I'm not mistaken, now I thought they discovered ice in some of the craters on the south pole of the moon. Now I can't turn this around. This is not a 3D model, but yeah, I thought they did discover water in some of the shadowed areas of the craters in the south pole that don't ever see light. But the Mare, no, the seas are just lava and very smooth. But they look like seas from the earth. That's why they got the name.
Yeah.
Kane, you had a question?
Remember how yesterday you mentioned that the moon is I forgot.
It'll come back to you. And oh, and don't forget, we want to see your coins.
This is a Slooh image. I don't know. There it is. So very nice full moon picture.
That is a very nice one.
And this is a full moon, since we have a minute or two. Aha. Aha. No, it's not full. Who can tell me why it's not full?
I see a crater on the side. It started with a G, but it's farther to the side than it should be.
That's Grimaldi.
So
This is
yeah,
Mare
that's-
Crisium. So again, we're seeing very clearly on the eastern limb, beautiful. We're seeing Mare Marginis, Mare Smithii, Mare Australe. We're seeing that. If you notice, I want you to look at the two limbs of the moon. The limb is the fancy word that we use for edge. Smooth, beautiful, beautiful, smooth, 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 smooth.
Crater.
Wait a second. Not so smooth. Not so smooth, not so smooth. This moon is not full. This is just before full moon. This would classify, in my opinion, as a waxing gibbous moon, and the moon is not full. It's almost full. I would say this is like 99.8% full. And the Slooh parameters will allow you, it'll say full moon, but it is either a lot of times just before or just slightly after full moon. Remember, full moon is actually a moment in time. How moment in time is it? Think about when we have an eclipse, right? An eclipse, a solar eclipse, which is when the new moon passes in front of the sun, anywhere from 1 to 7 minutes, depending on where the moon is in relation to the earth and how its orbit is. The moon moves 1 moon's width every hour. Now, I don't know the length of the full moon this month, but think of this. Remember, the moon is at opposition. You've got the sun to your back, we're the earth, and you've got the moon here. That moment of opposition is going to change as the moon changes, which means the way that the light is reflected is going to be affected. I didn't mean for that to rhyme, but it did. And this is what's happening. This moon has not quite yet moved into that position of opposition, because we see this jagged end. When it's at opposition, we don't see that. Usually, I see full moon pictures where it's just slightly past full moon. Remember, the moon is moving in this direction. It's moving from right to left, right? In its orbit around the Earth. It's counterclockwise around the Earth. So it hasn't moved into that slot yet. And eventually we will get that position on the right-hand side. I don't know, do we have time? Do I want to look for this? Let's see if I can find a picture real quick. I've got all
Okay,
my
do it.
I've got all my moon images loaded. Let me do this. I'll leave this up for the time. So everybody see why that is? That's why when you schedule, oh no, your full moon missions, you have to remember that you pretty much got one day to do it. They do cut you some slack in terms of time.
But you
Like,
might miss that moment.
they'll give you a night, put it that way, but you're not going to have several nights. Let me take a look at this. Oh, here we go.
Okay.
Why is it not working?
I don't know. It didn't switch.
It's going to switch. And I like this.
There we go.
So we can see, remember that jagged edge? That jagged edge is gone. That means we've already gone into opposition, but the jagged edge now
It's on
is
the
over
inside.
here. It's over here. So the moon has moved away from opposition. Remember the jagged edge was here? It was very obvious. It was clear. Now it's over here. It's because the moon has moved. It's moved past opposition, past full moon. We are slightly past the full moon. This is Tycho, that beautiful ejecta crater, right? The ray crater. We talked about the ray craters. This is Copernicus, another one. Here's Proclus. Remember this sideways thing where the meteor came in this direction. This is Aristarchus. The thing I liked about this, I'm glad I had this pulled in. I don't know why I had this image loaded, but I did. This was a picture taken by somebody who's here today. Anybody want to take a guess who that is?
I don't know. Is it Yudvin's picture? You?
No, this was your picture. This was a power shot image.
That's
Gretchen's
my
power
shot.
shot moon touched up. So this is one of the pictures that you shared somewhere, probably on Discord. Gretchen's power shot moon touched up, capturing the full moon just after the moment of full moon. And that's what we've got. So we see the difference. You can see the difference between the two. I think this is great. Let's 601, we're done. Let me go back to Jenny's moon, and we're going to see it. Okay, do you see the jaggedness? See what I'm talking about? We see some definition just ever so slightly before full moon. This whole area is the area nice and smooth. We're going to go to Gretchen's power shot moon. Everything is shifted.
Everything is shifted.
All right. With that said, I think this is a good place to stop for today. Lunar features. Wow. If you haven't started on this quest, remember you have to use Canary 4 to zoom in for a lot of it. And you're not going to get Canary 4 images, I think, until we're at somewhere in a gibbous phase. I don't think they even have quarter moons. Another opportunity for lunar images is Chile 3.
Ooh,
Chile 3 is a telescope which very rarely goes online. When it does, it's kind of a one-off thing. You have to be on Slooh watching the telescopes live, and all of a sudden, Chile 3 just goes live and it's on. It's a lot of fun when it does happen. There's usually a lot of chatter in Slooh chat, which doesn't exist anymore. Now we're on Discord. Kane, that's right. You have some coins you want to share with us. Go ahead. I'm sorry. I'll pin you so you can get a good look.
So,
Oh, okay. Wow. Yeah, you got them sealed and everything.
yeah, this was only given out on July 16th or July 20th. And then I also have this one. 50th anniversary. Another 50th anniversary. Minted that day.
Ooh, look at that.
Mhm.
And then I got a here. And
Wow,
this
where'd
is,
you get those?
well, some of them I got at the Cape Canaveral, and the other one I bought at a coin show. And here's the one I actually really wanted you to see. Now,
Okay.
this one,
Yeah. Okay.
Now-
Yeah, I have you pinned.
now this one contains medals from the Eagle and Columbia.
Okay.
Like the actual medal from the spaceship.
Yeah, Columbia was the I think the command module. It was the lower part, and then you had the capsule.
Parts of those medals.
I forget. Yeah, yeah.
Great stuff. Lovely souvenirs you've got there.
So we have a little show and tell at the end. I think we are going to call it a day. Lunar features. If you haven't started this quest yet, it's a good one to start. If not, if you don't feel like doing the quest, hey, you've got some insight now into what's happening with the moon. You can kind of demystify some of what we've looked at. And I hope that this was worth your time today, and that you have a working knowledge of what we look at when we look at the moon. It's not just the full moon or the whole moon. I mean, there's all kinds of stuff going on there. And that was our goal today, to talk about some of the what's going on. Tomorrow, we are going to break into the world of celestial mechanics and look at the way the moon moves. I think we're going to cover eclipses tomorrow too. Why don't we have an eclipse every month? If the moon comes between the Earth and the sun, well, that's the eclipse condition, sort of. And if we have the moon where it's at opposition, right, sun, Earth, moon, why doesn't the moon pass in front of the Earth's shadow every month? We should have a solar eclipse and lunar eclipse every month. We know that's not true. The moon is at about a 5-degree tilt. We'll talk about that tomorrow. We'll talk about mini moons, micro moons. That's not even really a term. That's like media. Okay, that's stuff that the weatherman talks about, the weather person. Something you might read in a magazine. But we will talk about why sometimes the moon is closer or further away from Earth. We will talk about libration, about that phenomena of how, even though the moon is tidally locked, we see more than 50%. We see 59% thereabouts, depending on where the moon is. So all of that and good stuff tomorrow. Thursday, I don't know, I think we'll do a wrap up. And then we'll definitely do a Kahoot, because I already have the lunar phase Kahoot done. We did that 2 years ago, first time. So we'll do that again. I'll stick in some lunar features. And next week is kind of our wrap-up week, strange space. We'll talk about those things that aren't covered. I definitely want to talk about comets. I think we'll revisit the supernova. We'll talk about the size of the universe and look at some models. We may go to that website on the size of things. We'll see how there is an exact parallel between as everything gets bigger, so it also can get smaller at two extremes. I want to talk about these Hubble deep fields and the James Webb deep fields, how we see that as we look at small parts of the sky, we keep seeing more and more gap. I'm getting way ahead of myself. Tomorrow, lunar movement, and we'll talk about celestial mechanics. All right, we're done. Thank you all for coming. See you tomorrow. Take care.
All right, everybody. We'll see you tomorrow.